a square. This is our square. Now in this square we have to divide this complete square into three portions. First one is this rectangle, second one is a square, and the third one is again rectangle. Now suppose if we cut this side, this is our rectangle, and paste it over here. Second one is if we cut this square region and paste it over here. And the third one is again, this is the shape of rectangle, we cut from here and paste it over here. So when we join together, this will make again a square. Now we know that this is a square, so let us suppose that the name of this side is A, and if it is a square, it means all the sides are equal in measure. So this is also A, this one is also A, and this side is also A. Now how we will calculate this smaller portion? So first of all we will say the name of this width of the rectangle is small b, and we know that if it is a rectangular shape, so if this width is b, obviously this one is also b. Now how you can calculate this complete length of the smaller rectangle? As we know that the length of this complete square is small a, so we will subtract this smaller portion of the rectangle and the width will be b. So if we subtract this b from the whole length of the square, we have a minus b, and we know that this small shape is a rectangle. So if this one is a minus b, obviously this side is a minus b, and this rectangle has a same length of the square length, so it is also a minus b. And if we know that this complete smaller shape of this portion is a square, so that's why if one of its side is a minus b, obviously this is also a minus b, this one is also a minus b, and this one is also a minus b. So all the sides of this small square is a minus b. Now we know that this side is a minus b, this side is a minus b. How you will calculate this smaller portion of the rectangle? As we know that the square of this side is a minus b and the whole square has length a. Now obviously if this side is b, and when we add this smaller side of the rectangle add with this side of the square, and the side of the square is a minus b, and suppose that this side is a b, and when you add this smaller portion b with the side of the square a minus b, and when you cancel these two sides, it is obviously a. So that means the complete length of this square is a. Now as we know that area of square is equal to side whole square. This is the formula of area of square, and we know that this complete shape is a square and all the sides of this square is a, so we will substitute over here. So it's a square. So area of square, it's a area of square which is equal to a square. Now when we pick this portion again and paste over here, now we will calculate the area of this side. because we are going to prove the other side of this identity. Now this is a square shape. Now how we will calculate its area? We know that area is equal to side square, and its side is a minus b whole square. Now we pick the second one, and second shape is the area. Second shape is rectangle. So when we paste it over here, and which is its length is a minus b and its width is bb, as we have already defined. Now what will be the area of this shape? This is the shape of rectangle, so that's why we will use the formula area is equal to length into width, and it will be, its length is a minus b and its width is, or breadth is, b. Now third one, if we pick this one and paste it over here, as we know that this complete length is a, and this is the width of the rectangle. So again this is the shape of rectangle, so again we will use the same formula, a is equal to length multiplied by width. So its length will be a and breadth will be b, and if we add all these areas, which is further equal to area of the whole figure, area of square, and whole figure is a square region. Now when we add a minus b whole square plus a minus b into b plus ab, which is equal to, and we have already calculated the area of square is a square, so we will write a square. Next step is a minus b whole square, and move these all these areas on the other side. So a square, which is this one, so we will move these areas on the other side. So it will be minus, when these areas are shifted on the other side, all the signs will be changed. So this is plus and it will move on the other side, it will be minus. A minus b bracket b, this is plus, it will be minus ab, which is further equal to a square, and outside is a b, so multiply this b inside the bracket, it's a minus, so multiply inside, it's a ab minus b square. Now further, a square, when you open the bracket, if outside is a negative sign, and when this sign is multiplied inside, all the signs will be changed. If it is inside is a plus sign, it will be negative. If it is a negative sign, it will be plus. So it is AB. So this sign is multiplied with this negative sign, it will be plus B square minus AB, which is further equal to A square. Now these two variables are same, so we will write AB minus AB plus B square. So arrange them. So next step will be A square minus, so here is a 1, here is also value 1, so both the two variables are same and their constant values must be added. So it's a 1, it will be 2AB plus B square. So A minus B whole square is our required proof of the second identity.